136 members were registered in their Google Docs. I request you to all the students have to register in first batch because of already second batch it's full. So try to join in the first batch, and I request you to kindly inform to your friends also. Please do not register with application number. Only few students they were registered with their application numbers. Because of it, maybe we are getting the problem when we are going to make out a list. So my sincere request is please register with admission number. Yeah. Please wait. Yes. In the last class, we have discussed about introduction of computers and computers softwares, and then except types of computers we discussed. And today we are going to discussing about types of computers, and again we see the program development and algorithm, problem solving, and flowchart presentations. That's also we see. Yeah, there are computers. It's divided into the three types depending on our requirements. One, it is an analog computer. Second one, it is a digital computers. Third one, it is a hybrid computers. In a analog computer, the word it's describing continuously. It's varying in a quantity, and it is accepting the data. That may be accepting the data means what we are giving the data, let's say the form of input, and input data it is continuous in the form, and output it is obtained whatever it's required to us. The data what we are giving or whatever data we are giving to the computer, and the formation maybe it is a different language we are use or codes we will using, and finally the result will get in the form of a different graphs or maybe in the form of a codes. That means these computers it's accepting the input what we are giving to input data, and it's giving to the output in the form of analog signals. The output it is measured on a scale. That means as per a scale it is measuring. That's a depend on their voltage, current, sound, speed, temperature, and the pressure, etc. And external features will be working. And suppose the values we can express in the analog data, and these values continuously, sometimes maybe it is increasing or sometimes maybe it is a decreasing, depending on their uh, fluctuation of the data. The analog computers, it's also used to measure the continuous values. Whatever values we are giving, it's useful to measuring the data. Example for the thermometer. The thermometer is the best example for analog to devise the uh, measuring of temperature, and it's filling by the mercury. The mercury column, it was designed in that one inside of the thermometer, and it's getting the fluctuation depending on the temperature, and it is showing the fluctuation movement. That's only just for example. Similarly, here also we can uh, measure the data depend on their data. Whatever data giving to the computer, it's a different. It's in the form of a different codes. Next one, it is a digital computers. Yeah, in digital computers, it's a depend on their digits. The word digital, it means a discrete, and it is referring as a binary system, which consists of only two digits. That's we know that the one it's a zero and second one it is a one. The digital data is consisting of binary data, and it is represented by uh, low and high. That maybe we see that as a off and a on. Like example on electrical switches, what we are identifying on off like that. It's also showing as a on off, and it is indicating as a low and high. These pulses are increased and decreased. Decreased in the discontinuous form rather than a continuous formation. The digital computer is a design. It's using the digital circuits, and which are there are two levels for an input and output of signals. Yes, definitely we every computer or every electronic device, maybe whatever data we are giving to that one, it's the form of a different codes. It's absorbing as an input data, and it's giving the data in the formation of a same code or utilizing the same codes, and it's giving the result as the output data. And these two levels, it's known as a logically, that's a logic 0 and logic 1. The digital computers can give a more accurate and faster results. Yes, the digital computer is well suited for solving complex problems in the engineering and technology. You know that we use in different techniques, and we'll use the different purposes, and we'll use in different applications. Hence, the digital computers have an increasing use in the field of design, the research, and other data processing. Not only in a specific field, we can use this digital data or digital computers in all the sectors now. Yeah, the digital computers, it can be further classified as a general purpose computer, and second one it is a special purpose computers. The special purpose computers is one that it is built for a specific application. General purpose computers are used for any type of applications. They can store different programs and do the jobs as per the instructions specified on those programs. Most of the computers that we see today for particular general computers. When you come into the hybrid computers, a hybrid computer combines its desirable features of analog and digital computer. That means it's consisting of a tool. One, it is analog, and second one, it is digital. It's mostly use automatic operations of complicated the physical processes and machines. Yes. Nowadays, we are using the data. That means the data where we can use either maybe it's converting into the digital or digital to the, and again converting into the analog. That means the data, whatever we are using to convert conversation and transforming the data into suitable conditions and suitable format and depend on our requirement. Just for example, if you can see in ICU, hospitals in ICU, we'll use their analog devices. It's might measure the patient temperature, blood pressure, and other conditions. And these measurements, which are in analog, might then convert into the numbers and supply to the digital components with a system. These components are used to monitor the patients in a vital sign and send into the signals. And if it is any abnormal readings which are detected by them, and then immediately we can able to identify the signals, and those signals will convert into the in digital mode. The hybrid computers are mainly used for special tasks. And what are the differences between the analog and digital? Yeah, analog, it's accepting input data in the continuous form, and output it is measured on a scale. And the same, when you come into the digital, it is accepting the input data. It's accepting the input data in a digital form, and the output it is received in a digital formation. You see, there is a differentiation between from first of these 2 point analog and digital. In the first one, accepting it is accepting input data in a continuous form, and output it is measured on a scale. But whereas if you go into the second case, that's accepting input data in the form of a digital, and again the output it should be it is released as a digital format only. In a first case, we are measuring the output data, but in second case, it's not measuring the data and it is releasing the data, or it's giving the data in a digital formation. Sometimes maybe analog data it has a errors. When it is the same result, it will be giving to outside also. But when you come into the digital, whatever data we are giving to the, or we are supplying the digital data, that should be accurate and the result should be also accurate. In case if you're giving the any error data, and then there may be chance to rectify the same and give the correct data. When you come into the internal memory of those internal memory, it's in the first case, I mean in analog computers, it's having the low internal memory. And when you go into the digital, in a digital case, it has a internal memory, it is a large. The analog computer, it is used only for the scientific industry and the medical fields, and it is a digital computers. It's useful in all the purpose. Generally, we can use that one. Analog computer, it is costliest, and when you go into the digital, it is not costliest. It is cheap. In an analog computer, it is not easily to program. Or if you go into the digital, you can easily to do the program. Yes. The processing speed and the storage capacity. Yes, we know that the computers, it's a different computers. We can classify again, depend on their capacity and depend on their memory, and we can classify as a four types again: the supercomputer, mainframe computers, mini computers, and microcomputers. Yeah, computers are classified according to their data processing, and they depend on the speed, amount of the data that they can hold. Who is this? Yeah. Yeah, coming to the supercomputer, it's a supercomputer. It's the most powerful and fastest, and also very expensive. And it was developed in 1980s. It is used to process a large amount of data and to solve the complicated scientific problems, and which can perform more than 1 trillion calculations per second. It has a large number of processors and connected to the parallel. So parallel processing is done in this computer. In a single supercomputer, thousands of users can be connected at the same time, and the supercomputer handles the works of each user separately. Supercomputers are mainly used for weather forecasting, nuclear energy research, and aircraft design to control the industrial units. That means here the supercomputer, it is working as a main server, and it's providing the number of networks. It's providing the number of networks, and it has a huge and a large number of processors, and it's connecting to the parallel. That means the network system it will be maintaining. It will maintaining the network system, and it's very fast. And how much I mean, whatever data if you give to the computer, it will be storing in their memory, and within a fraction of a seconds, the problems whatever it's created, and it will be solved by the same. And next one, it is a mainframe computer, and it's also looking as a large scale computer. But so when compared with the super computers, sorry, compare with the mainframe computers, the supercomputers are larger. But uh, these are also very expensive. The mainframe computer, especially, it's required a very large clean room with air conditioner, and it's very expensive to buy to operate. And also, it can support a large number of various equipments. It also has a multiple processors, and large mainframe systems can be handled. Again, whatever data we are giving to that one depend on our requirements. And at the same time, here also we have a chance to use the thousands of users. And the best example for this one, IBM and SPY 390 main frame, and it can support up to 50,000 users in different times. And there are basically two types of terminals which are used in the mainframe systems. Those are one, it is a drum terminal, and second one, it is a intelligent terminal. What about a drum terminal? Yeah, it's a calling two. There are a dumb terminal or dump terminal. Two. Yes. A dumb terminal. It's a dumb terminal doesn't have its own CPU, and it has a storage devices. This type of a terminal uses the CPU and storage devices of mainframe systems, and typically a dumb terminal consists of monitor and a keyboard or a mouse, and directly it's connecting with the main server. And second one, it is an intelligent terminal. It has a own processor and it can perform some processing operations. And the same time, it is also not having any own storage capacity. The mainframe computers are especially used as a servers on www, that means World Wide Web. The main frame computers are used in large organizations such as banks, airlines, universities, etc. and etc. That means here where the people they can use frequently and frequently access at the same data. Like example, server system. Suppose if you wanted to do the map designing, or example for if you're writing the online examinations, the same data will be displayed in all the systems, and it's maintaining by the one server. It's maintaining by the one server. The questions will be displayed different way, but it's maintaining the examination point of the pattern. The questions will be maybe the questions are different, but the working mode it is the same. Let's come into the mini computers. These mini computers we are looking in a smaller in size, and which are having a low processing speed, and storage capacity is also compared with compared with the other two mainframe and super. And these are all less expensive when compared with the previous two. Hence, the performance also will be less than that mainframes. The mini computers are used for business purpose and education and other government departments. Although some mini computers are designed for a single user, but most are designed to handle multiple terminals. Mini computers are commonly used as a servers in the network environment, and hundreds of personal computers can be connected in the network with a mini computer acting as a server like mainframes. Mini computers are used as a web servers also. And again, coming to the microcomputers. These microcomputers we can treat as our desktop or laptop computers. The desktop computers, we know that every day we are using the desktop computers. The desktop computers also known as or we are calling as virtual computers. They are usually easier to use, more affordable. They are normally intended for individual users for their word processing and other small application requirement. Whatever requirement for a personal purpose, we will use these type of microcomputers. Yes, we know very well about these laptop computers. Laptop computers are the portable computers. They are in very lightweight and which have a very thin screen. And these are also called as a notebook computers because of it's looking into the very small in their size, and they can operate on the batteries, and hence they are very popular. Yeah, one more it is handled computers. The handled computers for personal digital assistants, which are workable based on the pen based, and it's also working on the battery powered. We can see these are all in a small, and it can be carried out to anywhere. Yeah, please wait 5 minutes. Yeah. Next one, it is SRAM. It's a SRAM stands for it is a static. Whatever data we are giving or information, it's giving to the computer, and it's retain any information which is stored in the memory, and as long as the power it is maintained without any outside help, and the data whatever it's entered into the system, and then calmly it's waiting in the retrieval by the system command. Upon its receiving an order to overwrite the data, maybe it's a provide or it's a some data being it's a retained itself, and immediately the SRAM it's responding. It's one of the quality we can use in personal computers or microcomputers. And one more, it is a DRAM. DRAM it stands for dynamic. It's a storage the medium itself, and it's constantly changing. That means it's removing the data automatically. And DRAM, it's one of the cheapest forms of memory. Because of what is happening within a 5 or 6 minutes, the data it is going to be modified, or the data maybe it is going to be erased. Or sometimes maybe to visit each and every bit for many times, each and second we have to check and we have to edit the same what we are giving the input data to this one. Suppose if you wanted to ask, and maybe it's not having a memory because of it's not because of we are not giving the any storage capacity for this one. So that is the reason it's not remembering a long time. And then remind it's remember what it was given, or what data we have entered. Again we have to give, and then only it will be the data it will be available only 5 to 6 minutes. And the reminding process is called refreshing here, where the refreshing commanding we can use in a memory, and we have a variety of a sophisticated refreshing circuits which do nothing but travel through a vast DRAM memory and array polling to each bit for its content before it's fully forgets. And again we have to say, or we have to give the same command every time. Okay, this is about types of computers. And next one, it is a computer software. Yeah, next one, it is a computer software, and it's consisting of assemblers, loaders, macros, compilers, and application of software. Next one, it is operating a system. What's the purpose of operating a system, and types of operating a system, and how an operating system taking controls of the computer, and again different languages like commercial language, assembly language, high level language, and again language processor and programming language, and it contains generations. The computer software, how it will be working. The computer software, it's a depend on their program and how it will be enabled to the computer, and depend on their our requirement, and whatever program we are giving to the computer, and it will be performed on the basis of that language. And again, it's a completely opposition. I mean, it's a completely reverse of physical components. Like physical components means hardware. It's a quite opposite from this one, and it's an inclusion of a application, application of a software, such as it's contain a word processor, and which enable to user performer. And again, it's a depend on the system software. The system software is consisting of a operating system. The operating system is enabled to the software to run the program with the proper sequence. And when the program of a language or softwares introduced, the term of software, it was introduced in 1957 by the John W. Chucky. We know that the computer or the computer software, it's all related to the computer programs. In concept of this computer or programs, whenever we are going to the read or making to the programs, which are having different sequences, but even though which are having the different sequences, and we have to arrange in a correct sequence, and we will give the instructions to the computer. The computer software we can call is the contrast to the computer hardware, when it's encompasses the physical interconnections and the devices it's required to store and executing the program. Where it is executing these programs, these executing the programs, and which are located into the memory, and then it's association of a RAM. What about the software system? The system software, I mean software systems which helps to run the computer. The computer is having the hardware. That means these programs which are helps to display the data on a monitor. That means here the monitor, it is a hardware. That means internally it's a linking up, and then the program, whatever it is running and working and displayed on the monitor. That means internally which are having the connections. Internally which are having the connections, and they display the data. And again, it's having the assemblers and loaders. What is an assemblers? It's at a one time the computer programmer, it had is disposed of the basic machine that's interpreted through the hardware, and also it's containing some fundamental instructions. and the instructor or programmer, it's giving the instruction to the computer what he is going to making or what it is required to us. As per that, he will write a program and is giving the commands, and he is follow the some series. Series means in digital we have used the 0 and 1. Based on that, the series codes, and he will write a program, and those data it will be converting into the digital format, and the computer then only it will be understand. But actually, the programmers they'll face a problem when they are going to write a program in a machine languages, so that the more convenient language it should be used, the more convenient language it should be used, and to write the data in a symbolic way.
ఏందన్నా కొట్లాడుతున్నావేంటి మమ్మీ అట్లా ముందు ఎత్తుకొచ్చేసినావు? ఇది ఏంద్రా నాకు అర్థం కట్టింది శివ. బిజినెస్ నేర్పేయాలి అర్ష.
Okay, now coming to the introduction of a programming language. A programming language concepts. What is a programming language, and why are there so many programming languages we have, and what are the types of the programming language? Yes, do we need any programming language, or one it's need a new language or not? Let us see. The first one is what it is a programming languages. A programming language, it's a set of rules. That means it's a contain rules. It's a follow the rules, and it's a provide a way. It's telling to a computer that operation to perform. Whatever program you are going to make, and what it is required to us, as per that we'll provide some information or input data to the computer in the form of a digital, digital, and then the computer should be understand the same, and it's a giving the result. A program, it's a language. It's a set of the rules for communicating the an algorithm, and again it's a providing the linguistic framework for describing the computations. Yeah, whatever we are giving to the instructions to the computer, that should be in a form of a language. Then only it is receiving, and it's making the program, and it's solving the problems as per that, and it's giving the output, and it's reached over a target. A programming language, it's a national system for describing the computations, and it should be readable in a machine, and it should be in the form of a human readable format. A programming language, it's a tool for developing the executable models for a class problems in other domains also. Yes, in natural, when you come into the natural, English, it is a natural language, and we know that it has a different symbols and words and grammatical rules. And then, is there any chance the computer programming, I mean in a computer programming, is it having any rules? Yes, definitely. It has a rules. The programming language also it has a words and it's following the symbols and it's making the rules or the language. It's making according to the norms and rules of a grammar. And the grammatical rules we are calling here syntax. The word it is called as a syntax. Each programming language it has a own different set of syntax or different rules. Why are there so many programming languages? Why does some people speak French, English, or different languages? That's a nature of their own country and nature of their own nativity. As for that, they will use different languages. Likewise, here also in our computer, depend on programming languages or depend on the codes, and we use different languages. Programming languages have evolved over time as better ways have been developed to design them. When it was developed, the first program, the first program was developed in 1950s. From that onwards till now, there are different types of a language were developed. Different programming languages are designed for different types of programs. You see here levels of programming languages. High level program, and second one you see the low level program and executive purpose. You see here some machine codes. The first one you see, you just can observe. In a high level program, it's related to the class of a triangle method. The program we wanted to write in a high level programs, we have to write within a braces. You see here, the program if you want to start to write here, you can give some codes like a dots, depend on our requirements. We'll give the or we'll make a program, and that should be in braces. And coming to the next level program, that is a low level program, and we follow some codes here. As per that codes, the codes will converting into the language, and finally it will be displayed as a requirement of a language or our requirement of a program. And next one, it is a machine codes. It is useful for executing the program. And whatever language we are giving or whatever codes we are giving, when the program it is going to be executing, that should be converting into this, these machine codes. That's like a 001 or 001. That means depend on their letters. It should be converting into the machine codes. And again, we have a generation of a programming languages. One, it is a first generation language. Second one, second generation language. Third generation language. Fourth generation and fifth generation languages. These are all very basic concepts. Yeah, coming. The first one, it is a machine language. The machine language, again, it's a depend on their operations mode. Operation codes, we see that those will be useful like as a addition and a subtraction, multiplication, and those. How we can identify that? That the data, it's we can identify that, and it should be processed. And the machine language, it's a machine, it's a dependent, and it's a depend on the only one language. The computer, whatever it is, it's understand what we are giving the codes. The codes only, it's understanding, and it's giving the final output to us. But what about efficiency of this one? Yeah, it's depend on their codes. It's very difficult to identify, and it's very difficult to write the program with using of these codes in a first generation language. And second one, it is assembly languages or second generation languages. It's a depend on their symbolic purpose. That means the symbolic codes will use. These assembly language programs, or it's needed to be assembled for execution by the computer. And each assembly language instruction is translated into the again machine language. As per their instructions, it should be converting into the machine language. And it is easy to identify, or it is easy to write and easy to understand by the computer. And coming to the third generation languages, it's nearby to the English. What we will use here, simple mathematical notations. And again, the program should be written depend on their source code, and which must translate into the machine language programs which are called, that is, as a object code. The translation of a source code to the object, it's accomplished by a machine language or a system of a program. It is called as a compiler. Compiler, it is a source. Compiler is a source, and it's a source. It is a depend on the code, whatever object, that means whatever the program we are going to making, and the program, it is a depend on their source code. The source code, it is called as a compiler. The alternative to compilation, it's a interpretation which is accomplished by a system program. It is called as an interpreter. Yes, here that means slowly the interpretation, it is going to be applied, or the source of codes we are using for a different application purpose. Just you can see in a first generation language only, just we can use the codes. And when you come into the second generation, just mathematical problem will solve. And slowly again, I come into the third generation language. It is going to be using as application purpose. The different types of codes we are using here. It is called as a source code. The source code called it is as a compilation or compiler. Here, the interpreter or programmer, before writing a program, he will make source code. As per that, the source code, the program which should be interpreted, and the application will be applied in different ways. And finally, the interpretation which is completed, and the program it is called as an interpreter. And here we can commonly be used third generation languages. One is the Fortran, second one COBOL, third one C and C++, fourth one it is a Visual Basic. In the fourth generation languages, it's a nearby the high level language. It requires to few instructions to accomplish the task compared with the previous language. And here we will use the databases. We'll make the databases. Without a database, we cannot able to write the programs here. Those, it has a like example of query languages, report generators, forms designers, and finally we will use as a application purpose. A fifth generation language, it is a declarative languages and it's a functional also. It's interlinking languages. The programs may be changes. The work talks may be changes with using of the this fifth generation language. It's also called as a applicative language, and every function it will be done by this fifth generation language, and it's a depend on the mathematical logical program, and again it's based on the rule or based on the constraint work. The codes will be used, different codes will be used here, and that should be converting into as a machine languages. Yeah, depending on our requirement, we can use different languages within our limit. Yeah, it's a language family tree. It's known to us. Yeah, I'm stopping here. I have one more class now. I'm just going to shift to that one. We'll back at 1:45. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.